So let's take a look at this problem. Bar AB has angular velocity of 6 radians per second, terminal velocity of slider block C at the instant shown. So again, now this comes under the section of instance centers, but as I said before, we have to use stuff we've used previously. So let's take a look at this problem. And let's see, in this case, this was 30 degrees. And now, as usual, always keep this in mind. We know that this link AB is rotating about the point A. So we know that this velocity has to be perpendicular. And this block is confined to the x-axis, so we know its direction is like this. Now we can calculate the velocity of B because we know that this is turning at 6 radians per second. So we can find VB. Again, that's omega AB times R. VB is going to be 6 times 0.2. And VB is going to be 1.2 meters per second. And so again, remember, we want to find a place where perpendicular to lines to these velocities intersect. So if we were to continue, say, this one out here like this, and let's continue this one out here like this. And wherever they intersect here is going to be the instance center. And so we're going to have to find some of these angles here. Well, now, again, think about this. If this is 45 degrees, if there was another triangle right here, and this would be perpendicular, then this is going to be 45 up here. And also down here, if this is 30, this has to be 60 degrees. And so then what does this one have to be here? This has to be, let me just call this out. I'll call it phi. Phi has to be 180 minus 45. Minus 60. And so it looks like phi is going to be 75 degrees. And so that's 75 degrees like this. And we have most everything. We're going to now have to find these lengths. We're going to need to find length A and length B. And we're going to have to probably use the law of sines. So we can use the law of sines. Sine 60 degrees is equal to 0.5 sine 45 degrees. And when you solve for A, you get A to be 0.6124 meters. And then the same way we could solve for B. If we put B over the sine of 75, that's going to be equal to 0.5 over the sine of 45. And this is 683 meters like this. Now we have everything we need. Now it's just a matter of doing some basic calculations, really the same kind of calculations as this. Now, remember, we're working when we're doing this instant center, we're always doing it on for a particular link, and we're doing this now for link BC. And so let me write down we have here then. So you can see here the velocity of B is going to be equal to the angular velocity of BC times this radius A, and the velocity of C is going to be equal to the angular velocity of BC times this radius B. So let me write that down on a separate page here. Now we already know what velocity of B is. That was our 1.2. And we just found out what A was, 0.6124. And we calculate our angle, it will be omega BC will be 1.96, I guess, radians per second. Now we can use that to find the velocity of C. Because we already found the length B was 683.683. And that's 1.338 meters per second.